Morning. I hope you're all doing great. Grade 7. Our lesson for today is interpreting plans and drawing. So for the introduction of this lesson, farm plans and layouts, or what we call the drawings, are as important as anything like farm inputs and requirements. Before embarking on farm crop production, a design has to be drawn according to type of crop grown and its arrangement. Consider to the planting systems and the practices. In planning a farm layout, several aspects of farming have to be considered. This includes identifying lands that can be used for farming, planning crops to plant in the farm, and knowing the regulations and applying appropriate irrigation system. Our objective for this lesson are: number 1, interpret plans and layout; number 2, interpret irrigation plans and drawing; and of course, calculate the number of plants layout. First, let's talk about site assessment. So, an ocular inspection needs to be done for an on-site assessment of the farm. A map can be drawn of the properties, topography, boundaries, soil, water resources, etc., and then a business plan can be formulated. One must be acquainted with certain Philippine laws regarding use of lands in farming. The Republic Act 8435, or what we call the Agriculture and Fisheries Modernization Act, or AFMA, details the regulations in identifying areas that can be used for agriculture. Cooperate with the regional office or the Department of Agriculture to know if the property is suitable for farming. Consider the criteria used to include a land in a strategic agriculture and fishery development zones, or SAF-DZ, listed in Section 6 of the AFMA. Number 1, agroclimatic and environmental conditions giving the area a competitive advantage in the cultivation, culture, production, and processing of particular crops, animals, and aquatic products. Number 2 is strategic location of the area for the establishment of agriculture or fisheries infrastructure, industrial complexes, production and processing zones. Number 3 is strategic location of the area for the market development and market networking both at the local and international levels. And of course, number 4, dominant presence of agrarian reform commodities, or ARCs, and or small owner cultivators and amortizing owners, agrarian reform beneficiaries, and other small farmers and fisherfolk in the area. So these are under the government plans. Arrangement of crops in row planting. So what is a row planting? So it involves growing seeds in straight line. So it is the traditional way of planting vegetables, crops, and trees. So in a farm layout, planning the crops to plant is a must to help make farming more efficient. A common method of planting is row planting. So wherein crops are planted in either single or multiple rows, whether in monocropping or multiple cropping. Row planting is preferred to maximize yields and for convenience, so planning how the crops are arranged in row planting depends mainly on the topography of the land, which is shape, terrain, or slope. Then also, it depends on the irrigation lines and other physical barriers. So row planting is preferred over broadcasting or scatter planting because of the following reasons. Number 1, efficient photosynthesis and improve crop yield. Number two, an increase of gas exchanges and prevention of excessive humidity. Number three, ease of cultivation, weeding, howling, and other farm operations. Number four, convenience in movement, which allows close inspection of individual plants. And number five, it enhances visibility. Row planting arrangement. So crops planted in this method are arranged in equidistant single rows or in multiple rows. In monocropping, plants are usually arranged in single rows. So depending on the crop, farmers used various system of planting arrangement. The common methods are the following. So we have the first one, which is called the hill method. So the crops are arranged in uniform distances or a single or a group. Next, we have the drill method. So in this method, a uniform number of plants for linear meter is considered. Next, we also have the spatial arrangement. So this is for row planted fruit trees and other perennial crops like coconut, oil palm, and rubber. It may be square, rectangular, king kongs, and triangular or hexagonal. So let's talk about types of planting. The first one is what we call the ridge system. So the ridge planting system is commonly used in large-scale garden plots and farms. In this type of planting system, the soil is cultivated into ridges but usually untilled before planting. Next, we have the raised beds. So the raised bed planting system is a system where plants are planted in a large boxes, which are usually made from bricks or wooden crates. Raised beds are filled with rich compost, which makes it as an alternative to soils containing too much clay or sand. The last one is what we call permaculture. So permaculture is a planting system that emphasizes sustainable use of land and green gardening practices. So the primary elements of a permaculture garden includes number one, the use of compost and mulch, which both increase soil fertility and discourage weed growth. Number two, a no-dig planting system, which preserves soil structure and prevents damage to plants. So permaculture planting system are ideal for home growers who have limited gardening space but desire homegrown products. Now let's talk about orchard layout. So when you say layout, this is a positioning of trees, crops, drainage, water source, roads, and buildings in an area. So the advantages of having a layout are number one, the facility and ease of operations. Number two, prevention of possible problems that may arise in the future. And number three, maximizing planted areas and optimizing plant development and production. Systems of layouting used in orchard. Number one, or the first one, is what we call the square system. So in this system of planting, the trees are planted in a four corners forming a square which have equal distance in between rows and in between plants in the same row. So as you can see in the picture, we have a problem. So if you want to compute the number of plants using the square system, you are all you have to do is use the formula A divided by D times S, where A is area, D is distance, S is equal to space. So example, the given area is 1 hectare, the distance is 4 meters, and the space is 4 meters. So our solution is now follow the formula. So the number of trees or plants is equal to, so what is our area? So our area is 1 hectare. So we need to convert the hectare into square meter. So it becomes 10,000 square meter divided by distance and space, which is 4 meters by 4 meters. So is equal to 10,000 square meter divided by 16 is equal to 625 plants per hectare. So that is our answer if we use a square system. Next system is what we call the King Kongs or diagonal system. So in this system of planting can be done following the square system and an addition of a tree in the center of each square, which is called the filler crop. So if we're going to know the number of plants using the King Kong system, so we are going to use the formula area divided by distance times S plus R, which is row minus 1, and then H, which is hill minus 1. So example, the given R area is equal to 10,000 square meter. Our distance is 2 meters and the space is 2 meters. So row is 100 divided by 2, so that is equivalent to 50, and yield 100 divided by 2, that is equivalent to 50. So row and yield is constant. So for the solution, the number of plants is equal to our area is 10,000 square meter divided by the distance in the space is 2 meters by 2 meters, and then we plus the row, which is 50 minus 1, so that is 49, and the hill is 50 minus 1, that is 49. So simplify. So 10,000 square meter divided by 4, that is 2,500, and then 49 times 49, that is 2,401. Then add 2,500 plus 2,401, so the total is 4,902 plants per hectare. So that is our answer. Next system is what we call the double row system. So in double row system, we use the formula number of plant is equal to area divided by distance times space plus interval divided by 2. 2 is constant. So let's have an example. So our area is 10,000 square meter. The distance is 2 meters and the space is 2 meters. And our interval is 4 meters. So for the solution, follow the formula. For the area, we have the 10,000 square meter divided by the distance is 2 meter, our space is 2 meter, and then the interval is 4 meters, and then divided by 2. So remember to simplify first uh, the lower part of the problem. So 2 meters plus 4 meters, that is 6 times 2, that is 12 divided by 2, that is 6. So 10,000 square meter divided by 6, our answer is 1,666.66 plants per hectare. Next system is what we call hexagonal system. So in the hexagonal system of layouting, crops are planted at the corners of a hexagon. So 6 trees are planted in all corners of the hexagon and one in the center. So this system will yield plants 15% more as compared to other systems. However, farming operations can be quite difficult. So in this system, we use the formula to estimate the number of trees to be planted in the hexagonal system is a square system plus 15%. So for the solution, like for example, we already computed the number of square system a while ago. So that is 625 plants. So multiply that in 15%. So the 15% of 625 plant is 93.75 plants. So and then add 625 plus 93.75. So the number of plant using hexagonal system is 718.75 plants. The last system is what we call the contour system. So, is said to be applicable in hilly areas. So, it is done by connecting all points of the same elevation across slope using an imaginary line. So, in contour system of layouting, this is done in land with elevated topography such as slopes and hills. So, this system can control erosion and can preserve nutrients of the soil by conserving water. Now let's talk about multiple row planting arrangement. So multiple row planting is a system where crops are arranged in the multiple rows or blocks. So the blocks can have allotted space in between which may be planted with other crops. In this arrangement, more crops can be grown in the same piece of land. So like for example, the coconut and other perennial crops are often intercropped with multiple rows of annual crops like corn and pineapple. So this is to maximize the area and maximizing the use of vacant interior spaces when the main crop has not fully developed. So thus allowing sufficient light exposure. So in vegetable production, the common practice is to plant in plots having multiple rows. A space between plots is provided for passage. Now, how about spatial or spatial arrangement in intercropping? So, spatial arrangement is the systematic apportioning of the farm area or any growing surface for crop production. So, in multiple cropping by intercropping. So, the crop can be planted in any of the following. So, number one, within the rows of the main crop. So the intercrop can be planted within the same row as the main crop, encouraging inter-row cultivation. So the disadvantage is that the intercrop will have less exposure to sunlight. Number two, between the rows of the main crop. So the intercrop can be planted between rows of the main crop. So if the main crop is corn, peanut or mung bean can be planted between two adjacent rows of corn. Number three, replacement series. So in this method, one or two rows that are supposedly planted with the main crop can be replaced with the intercrop. So similar to this is strip intercropping, which results in multiple row planting arrangement. So an example is growing 6 rows of corns and 12 rows of soybeans at the same time in alternating strips. Now let's talk about interpreting irrigation plan and design. So worldwide, about 70% of water used is in agriculture for irrigation. So the need for irrigation is greatly felt because of severe drought that affects large areas. So short periods without rainfall ruin crops and affect flood production. So what is irrigation? So irrigation is the application of water to the soil for the purpose of supplying the moisture essential to plant growth. It supplies water at a time when growing crops need it most. So it is therefore a more efficient way of supplying water to big farms. Several irrigation methods are available and the selection of one depends on water availability, crops, soil characteristic, and land topography and associated cost. So proper design of an irrigation system is based on the pumping system so that the pressure and the flow rate are efficiently provided. So irrigation water management should determine the time to irrigate, the amount of water to apply. So the main management objective is to handle effectively the production system for profit, not discounting environment and water availability, and the irrigation scheduling considering the irrigation method and other field or filed characteristic in one prime activity of management. Functions of farm irrigation system. One main function of farm irrigation system is to supply crops with irrigation water in the quantities and at the same time it is necessary. So specific functions are as follows. Number one, diverting water from the water source, conveying it to individual fields within the farm. Number three, distributing it within each field. And number four, providing a means of measuring and regulating flows. It is also helps in controlling wind erosion, delaying development of root and bud, and the cooling crop and soil. So the tasks such as applying chemicals and waste and providing water for seed germination are made easier with this system. Reasons for irrigation plan. So an irrigation plan is important for the following reason. It enables the designer to lay out the irrigation system in the most cost-effective way. So a material list and the anticipated project costs are generated and evaluated respectively. Number two, it provides detailed information on system installation. Crop spacing, sprinklers, pumping requirements, pipeline sizes, and lengths are vital information to be included in the plan. If roads, trees, gas, oil, water, telephone, or transmission line become obstructions, they ought to be stipulated. Number three, it sets out the specification, design standards, and work schedule as basis of any contractual agreements between the installation contractor and the farmer. And number four, it furnishes a record for future reference. So it can be used for overall farm planning and expansion potential. Now, let's talk about essential features of a plan. First, the topographic data. So the field shape must be accurately drawn, showing pertinent obstructions, features, and elevation details. Next, water source capacity. So the water supply must be clearly indicated, showing location and available capacity. The third one is major irrigation structures. So the irrigation plan should be in consultation with the National Irrigation Administration, or what we call the NIA. It is a branch of Department of Agriculture that is responsible for irrigation development in the Philippines. The fourth one is soil and crop characteristics. Soil and crop limitations must be considered to reduce runoff and deep percolation because of mismanagement. Number five, design parameters. Soil water holding capacity, maximum application rate, and the climatic or climate data should be used to select the correct irrigation system design. Number six, design data. The nozzle selected, operating pressure, discharge rate, and sprinkler spacing ought to be in the plan. The irrigation interval, set time, application rate, and net amount applied need to be calculated as well. Now let's talk about the different designs of irrigation systems. Below are the various designs of irrigation systems based on the standard procedures. So we have the surface irrigation. So when you say surface irrigation, water is applied to the field in either the controlled or uncontrolled manner. So the types of surface irrigation are as follows. We have the first one, the furrow system, and the border irrigation system. Then we also have the basin irrigation system. For the furrow system, Furrow irrigation with siphons and furrow irrigation by cutting the ridge. So that is the types of furrow system. The characteristic of our furrow system are moisture in the root zone, application of non-erosive streams, use of a reuse system or a cutback stream, good land preparation, appropriate design and experience, labor, use of machinery for land preparation, cultivation, farrowing, and harvesting, etc. For another types of surface irrigation, which is the border irrigation system, the characteristic of this are practice of controlled surface flooding, crops that can withstand flooding for a short time like wheat, soils between extremely high and very low infiltration rates, gradual application of water to be or to the root zone. No runoff and deep percolation, and also determination of right time to cut off the inflow. So that is the characteristic of the border irrigation system. For the third types of surface irrigation, we have the basin irrigation system. So in this system, the characteristics are ideal for irrigating rice, normally flat area, a very high stream size introduced for rapid movement of water, closure of water inlet to avoid water loss in the pond, reduction of opportunity time difference between the upward and downward ends. Then another irrigation system, we have the drip or trickled irrigation. So the characteristic of this are water is applied directly to the crop, water is conserved, weeds are controlled, there is a low pressure system, there is a slow rate of water application, there is slow rate of or reduced evaporation, there is no need for drainage system. Next irrigation system, we have the sprinkler irrigation. So this is ideal in areas where water is scarce. So it conveys water through pipes and applies it with a minimum amount of losses. So water is applied in the form of sprays, sometimes in simulating natural rainfall. So if it is well planned, designed, and operated, it can be used in sloping land to reduce erosion where other systems are not possible. So we have different types of sprinkler irrigation. We have three actually. Number one, we have the fully portable system. Number two, the semi-portable system. And the last one, the fully permanent system. So let's talk about the characteristic of a fully portable system. So in fully portable system, designed to be moved from one field to another or to other pumping sites that are in the same field. The semi-portable system, the characteristic is the water source and the pumping plants or plant are fixed in locomotion or location. Other components can be moved. Next, we have the fully permanent system. So in fully permanent system, the characteristic, it can be used on permanent irrigation fields and for relatively high value crops like orchard and vineyards. Factors to consider in layouting an orchard. Site. The topography of the land refers to the physical features such as mountains, hills, slopes, and bodies of water. Erosion usually occurs in slopes and hilly lands which need to be contoured for farming. The best site for a vegetable garden depends on the kind and variety of crops to be planted. Lowland crops like eggplants, pole beans, and squash are best grown in the plains, and highland crops such as sweet potatoes, brassicas, and carrots are grown well in the cool mountainous areas. Soil types: sandy loams and loamy soil are best for most crops. Clay soils easily dry up when exposed to too much sunlight and erode easily with too much rain. Testing for soil type is an essential practice in farm planning. Water sources. The best site for an orchard is near a water source. Irrigation canals, lakes, streams, and rivers are good source of water for a farm. These water sources provide the farm ample water for these crops as needed and may also be used to set up a system to drain excess water during the rainy season. If this body of waters are not present, deep well water sources become necessary. Next, we have vegetation. In planning an orchard, it is important to set aside sections of land for endemic vegetation to maintain and protect the natural habitat of wildlife. These areas are forests, swamps, marshland, and wetland which are home to endemic flora and fauna. In addition to this, maintaining sections of endemic vegetation in the area lessens the effects of soil depletion that may lead to erosion and drought. Now let's talk about the procedure for layouting or layout. First is to measure the land. Next, decide the types of plants or trees to be planted and then planting distance and the system of planting. Third, prepare a plan on the paper marking all the details.